Hello, everyone, and welcome to another Giatec Scientific on-demand webinar. And today we're going to discuss artificial intelligence in concrete and how this topic is pushing even more the boundaries of knowledge in the construction industry. So we have intelligence in several other fields, but we didn't see AI applied deeply in concrete technology. And this is what we're going to discuss today. And for those who don't know me, my name is Icaro Mariani. I am the manager of engineering solutions here at Giatec Scientific. So I have a bachelor's of civil engineering. I also have a master's degree in construction engineering and more than 10 years of experience in the construction industry. And I hope the topic that we're going to discuss today brings some more knowledge to you that are watching. So I'm going to start here with our vision. So the vision at Giatec is to truly revolutionize the construction industry, from batching the concrete directly at the batch plant and transporting this to job sites. So placing the concrete, controlling the temperature and strength, and to make sure that our job sites have enough durability and the quality parameters that they are required to have. So this is the vision of Giatec. We've been putting so many efforts and money towards research and development, and this is the result. You're going to see some of the results that we're getting today. So touching a little bit more on Giatec Scientific, we have a world presence in most of the countries on the planet. So if you see here, the green map is kind of covering the majority of countries that we have. So Giatec is present throughout the world, and several customers are already using our sensors and our technology to expedite processes at job sites and check concrete durability in a much quality way. You're going to also notice that we're based in Ottawa, Canada, but we have dealers at different locations that can support whenever you are in the world. Our main product is the SmartRock sensor. So the SmartRock sensor is a dual temperature sensor that measures temperature and strength at the bottom and at the tip of the white lead that we see over here, and also inside the logger, inside this black box, we also have a measuring sensor. So it's a dual temperature sensor that can catch different parameters in your concrete placement, in your in-place concrete. So this is the sensor that is revolutionizing also the construction industry. Our agenda today is going to follow like this. So what is artificial intelligence? AI in concrete. We're going to introduce you to Roxi, our AI system. AI for pouring time, AI for mix validation, AI for mix optimization, and SmartMix. We're going to discuss all those 6 topics today. And by the end of the presentation, if you have any questions, you can put those on the chat so we can answer those later on, as this is a on-demand webinar. So what is artificial intelligence? What is this? So we have Google Home or Alexa at home, and they are trained, and they are being trained even more to anticipate problems, solve issues, and make our life easier. So what is artificial intelligence? So it's the science of providing computer systems the ability to automatically learn and improve from an experience without being explicitly programmed. So the good thing and the nice thing about AI is that it is a continuous process. The AI that we have today is no better than the one that we're going to have tomorrow. So it's a continuous process. So it's basically a machine learning. So how do we train a AI system to work? For example, if you're purchasing something, state of marketing, if you type on Google, for example, Google is going to automatically provide you insights of what you're searching for. If you type for pillows, for example, It's not going to only show you pillows, it's going to show you different types of pillows, different sizes. And this is the concept behind it. The AI system is going to allow our lives to be easier. And that is the goal also when we apply AI in Concord. If you see on the right-hand side, we also here select all the images with cars. This is the way that we can prevent a machine, for example, from passing a human test here. So there are ways that we can train AI system to detect if they are dealing with another robot or if they're talking to a human, for example. So this is the process. So AI system is something very broad, and we could spend a month here just discussing AI, and still we would have more topics to discuss. So what is machine learning? So we have the input data and we labeled the outputs. So let's automate the decision process. So for example, how do we make a machine to learn if a picture is a dog or a cat? So there are different patterns, there are different characteristics in a dog's face versus a cat face. So if you compare, for example, a cat versus a dog, we can have points, or we can find a pattern that all dogs have as opposed to cats. So the size of the ears, the size of the eyes, the type of the nose. So we're gonna see that we have more landing marks on the blue side for dogs and cats, as opposed we're gonna have more red dots or landing marks on the left-hand side here as an example. So once we establish that the majority of characteristics from a certain, for dogs, they land on a specific side, we can automate the machine to learn that a specific type of ear, a specific shape of ear, or even the tongue, or different characteristics, is going to refer to a dog as opposed to a cat. So this is how the machine learns to differentiate between a cat and a dog. So this same process can be done for different subjects. If we want to compare a laptop versus a computer, if we want to compare a specific type of washing machine versus other washing machines and the pattern when they are washing. So this is what machine learning is about. So how do we apply the machine learning and artificial intelligence in Concord? So that's the big deal. How do we convert what we have so far in different industries to our old-fashioned industry? And let's be honest, the majority of our, not old-fashioned, but we are still improving in when we talk about AI learning in construction. So we have Roxi. So who is Roxi? So it's the first AI program created for concrete testing. So since April 2019, Roxi has been trained for concrete pouring time, concrete performance prediction, and mix optimization for carbon emission and cost. So those are the three main aspects that Roxi covers right now. However, she's still learning. We're still collecting data from different job sites, from different projects, to further enhance who Roxi is and what she can provide our customers. AI for pouring time. So let's discuss one by one the three topics that Roxi already makes a difference in our everyday project life. So for pouring time, so goal. The goal is to suggest a pouring time based on the temperature history of your concrete. How is that? It was trained over 10,000 temperature curves in concrete and identified the pouring time. Imagine that you are placing your concrete today. Your placement time, so your pouring times starts at 7 a.m. And then you're going to install one sensor at the beginning of your pour, one at the middle, and another one at the end. Imagine that we have 100 trucks delivered today. How can we know for sure when the concrete is touching the sensor? There are two options. You can have someone, so a team member at the job site, manually taking notes. Hey, right now, concrete 8 just started pouring on top of sensor 1 or sensor 2. But that requires time. And there's an easier way to do that. So if we build a system in which our AI embedded system can know the sudden change in the temperature. So let's say it jumped from 60°F to 75, or even if the hydration process is started. So it is at 72, 73, and then slowly starts to gain temperature due to the hydration process of concrete. So if we train a machine to learn what is a typical concrete temperature curve, or what is the typical sudden change in the temperature from ambient condition to concrete temperature, we can teach our system to identify when the concrete touched the sensor. And this is what Roxi already does. So what is happening here? We have 3 screenshots, but the most important one is the one on the right-hand side. So this is what I was talking about. If we don't know for sure what is the time that the concrete is touching the sensor, we don't have a precision with the strength prediction. Why is that? If we tell the sensor that the concrete was placed at 10 a.m., but really the concrete was only placed at 3 p.m., we have a 5-hour gap there. We have a 5-hour in which the system is calculating strength out of nothing because there was nothing touching the sensor. However, if we have an intelligent system in place that tells us, hey, the suggested pouring time is not 10 a.m., it's 3 p.m., because you had a large pour, we can have a more precise strength prediction. We can have a more precise and more conservative approach towards our concrete control. So this is what Roxi is already doing. And this is super important as well, because if we don't have a precision with the pouring time, we could remove forms, we could stress cables, so we could perform critical operations that are also a safety matter for workers on site in a non-conservative way. If you know when the pouring time is, we're being conservative with your strength prediction, and therefore to perform the critical operations in a safely manner. So this is what Roxi already does. She can propose us the correct placement time of our sensors based on the hydration process, based on what the sensor, based on what the concrete is releasing, the heat dissipated, the heat release of our hydration process. AI for mix validation. So right now we discussed something that's already implemented. Just going back, if you want to know how this works, I encourage you to download the SmartRock app on your phone, log in, you could do that as a guest just to visualize the demo project. There's a demo project there, and you can change the pouring time from that sensor. And you see that Roxi will eventually suggest the correct pouring time for that sensor. So the SmartRock app is free for download on Google Play Store and App Store. So if you want to check it out, you can go there and play around with the data, the demo data that's available in the app. AI for mix validation. So once we saw that everything was implemented and the results we were getting, they were fantastic, we started, let's push this a little bit further. And how can we do that? We can do that with AI for mix validation. And how does it work? If contractors and labs performing maturity calibrations throughout the world with our system, we need to validate if the maturity calibration is right for the mix design. Why is that? Sometimes when performing a maturity calibration, when you are inputting the numbers, maybe the datum temperature is not the correct one. Maybe you use a number that doesn't make sense. For example, if you enter a datum temperature at 32, but you're using the metric system, maybe you didn't select the correct measurement system in the first place. So this is what the AI system for mix validation is going to jump into. So our Roxi was trained on thousands of mixes and break results collected over multiple years. So the advantages of this system is that it uncovers human error based on maturity calibrations. So imagine that we're having a super high maturity index with low break results. Maybe you are inputting a maturity calibration for flex roll instead of a maturity calibration for compressive. So it detects error messages, errors based on mixed proportions and suggests improvements based on maturity points. So based on the maturity points that the system was trained over the years, it's gonna know if your mix is making sense. If the maturity in Fahrenheit hours versus PSI, compressive strength in PSI, or Celsius hours versus strength in MPa makes sense if it is actually a good fit for the maturity calibration. And implementing this, how do we implement? So the SmartRock technology leverages the concept of concrete maturity to determine the in-place strength. And the maturity requires the maturity calibration, as we were talking before. So we need garbage in and garbage out. So Roxi is going to process this. So the input from the user is going to be the maturity calibration data points and the mix design. So we're going to input the mix proportions, the specified performance, and we're going to also enter the maturity points. And the system is going to output if it found any issues. For example, Roxi is going to suggest, hey, the entry strength values seem to be high for the entry mix proportions. Imagine that we have a mix with a water to cement ratio of 0.6, no accelerators, no nothing. And then at one day, we are outputting 4,000, 5,000 PSI. So Roxi can check that and, hey, maybe there was something wrong here. Or Roxi can also confirm your mix looks good and Roxi found zero issues. So this is what Roxi is already doing. And this is just an example of how the input happens. So we have the mix information, such as maturity in Celsius hours versus strength in MPa, or also Fahrenheit hours and PSI. So it doesn't matter the system as long as you choose one. The mix calibration, and then the mix proportions. So the mix proportions, Roxi allows us to input cement, water, fine aggregate, coarse aggregate, fly ash, high range water reducer, silica fume, slag. So there's a variety of components that you can add to your mix here to validate your mix. An example of output is, as I said, the mix looks good, or if the entry strength results are not in conformity with what you told the system that the mix would perform. Now jumping into mix optimization is a little bit different. So in the first case that we were looking before, so we discussed pouring time, we discussed validation that just checks if the mix looks good. And lastly, right now, we are already doing mix optimization. So what is the mix optimization? So the goal is to determine if your concrete is over-designed and propose solutions to reduce the cement consumption and the cost of the mix design. Typically, the most expensive material in any mix design is the cement. So if you can reduce cement, you are reducing cost largely. If you reduce, let's say, 10 pounds of cement, 15 pounds of cement per yard, you're over a course of a month or a year, you're saving thousands of dollars or even millions of dollars, depending on your volume. So how? We use the same database for training, but also incorporated the fresh properties of concrete. So the user input in this case is mix design, fresh properties, so area in slump, and specified strength. So what is the target? Is your target 3,000 PSI in 3 days? Is your target 8,000 PSI in 14 days? You know, no matter what is your target, we're gonna also enter the target into the system. And then what Roxy is gonna do is gonna propose enhancements to the mix. So your mix looks good. It's perfect, but it could be better. So it's not perfect. So you can reduce cement content. So the first option that Rox is always going to propose is that you can reduce a certain amount of cement if you keep the same water to cement ratio. However, in this case, we are damaging our workability. So if you don't want to do that and you want to keep the same workability without adding more additives to the mix, that sometimes this could be expensive, you can reduce 3% of cement in this case by keeping water to cement, by keeping the same water content. In this case, we're slightly increasing the water to cement ratio a little bit, because if you're reducing cement and you're keeping the same water, you are increasing your water to cement ratio. That, of course, is going to reduce your strength. However, your mix is already over designed. So you are removing cement, which is the most costly material of your mix, in lieu of water in this case. So this is what the system has been trained to do. So Roxy can identify those opportunities to enhance the mix and propose this to the user. So how does it work? So now, for example, we have our strength chart, we have our points, and we have 1% reduction and 2% reduction. So this is how the system is gonna, in the back end, make the calculation. So the green line, we have our real concrete mix design. So we have a curve throughout, you're gaining strength throughout the time. If we reduce 1% and if we reduce 2%, we're gonna see if we're landing within the points. And that's how Roxy can propose. So with this huge database in the backend, Roxy is going to be able to propose those enhancements to the mix. And just as to show you a little bit more how it works, so the mix proportions, what we're talking about, cement type and quantity, gravel type and quantity, also sand and admixture type of quantity. You are using an adva, you are using, a glinium. If you're using different types of additives, you can input that and denote, for example, the type, the name of the supplier of additive as well. However, the type of additives is the most important thing. Also, weather and strength data. So those are the inputs into Roxy. And what Roxy is going to spit out is the strength prediction to the future. So air and strength did. So those are information that Rox is going to be able to provide the user with. Not air, but the strength prediction. Not this, sorry, the mix enhancement. So in terms of this implementation here, I was discussing, for example, if we have a mix that we can reduce 3% of cement if we keep the same water content. I'm going to exemplify with this, a cement saving in a PT deck, so a post-tension deck. The design strength is 6,000 PSI, but the target strength is 3,000 PSI. So we have that, we have our maturity calibration, we have our mix. So let's run this mix with our system. So in our system, we have this. So I'm gonna click on this, my mix on my cloud. And for example, my mix verification example, and how Roxy verifies. Gonna add it. And those are the fields that I'm gonna populate. I have 450 pounds of cement per cubic yard, 300 pounds of water, 1685 of fine aggregate, 2000 coarse, 160 of fly ash, and I using also high range water reducer. Then I'm gonna input the age. So I wanna achieve 3000 PSI in 3 days. I can also put a safety margin, let's say 9% or 10%. It's up to you, the safety margin. This lamp and the air content. Once I save this, what Rox is gonna do is verify. So based on the maturity calibration that we have our points, we have the maturity calibration. we have our A and B factors. So based on a log 10 curve, we're gonna have our proposed enhancement to the mix. So with that, we can go back to our mix proportions and enhance our mix. So now is where I'm gonna exemplify what happens. So going back to our case, we have a target of 3,000 PSI. So the mix one, let's imagine that we have 600 pounds of cement per cubic yard, 250 of water. So I did the rundown with our system, and this is our mix design. We start breaking our cylinders, our sensors. You know, we have our sensors installed, and the 3-day target strength 3,000 psi, but the 3-day sensor is showing 3,500 because we're benefited from the high hydration process in a mass element. So there's a 500 psi difference here. Taking that into consideration, we are 500 psi above what we want, right? So the possible cement reduction here is 4% according to Roxi. So let's reduce 4% here. So the cement now is 576 with the same water because we don't want to lose workability. We are increasing the water to cement ratio a little bit. So for 0.416 to 43.4. And our 3-day sensors are showing 3,200. So we're still above the 3,000 PSI mark, but we are not overperforming. We have a good performance here. When we take this number into a full pour, the number gets more significant. So the mix one had 600 pounds. The second mix, the enhanced one, had 576. So we're talking about 24 pounds difference per yard. If we have a 500 yard pour, we're talking about 6 tons of cement. 6 tons. If we calculate that in CO2 emissions, we're talking about roughly 5 tons of carbon reduction. Why is that? Because the average CO2 emissions in a factory, it varies from 0.8 to 1.2 tons of CO2 emitted by ton of cement produced. So as an average, we're reducing 5 tons of CO2 emissions just using AI. Now, if we look into an entire project, this is even more significant. The same case here, the same target, however, in 15 floors, 2 pours per floor. We're talking about 180 tons of cement saved and almost 150 tons of CO2 reduction. So this is something that we're working towards. We are working in solutions to enhance the mix, to reduce costs, to reduce CO2 emissions. So this is what Giatec has been doing in the past years. We've been building this huge database that will allow contractors, clients, producers to enhance their mixes and reduce impact to the environment and also save money. And moving forward here, we're going to touch on the smart mix. So we discussed mix validation, the pouring time. We also discussed mix optimization. Now the smart mix. What is the smart mix? So it's also an AI-based platform. We can predict the mix performance. We can optimize mix proportions. We can reduce cement usage. So the beta version of SmartMix, if you type it in SmartMix on Google and then with Giatec, you can find this for free just to start using it and see how it works. Basically, you're gonna give the system what is your specification. I need, let's say, I need 4,000 PSI in 7 days. I need this slump. I need X, Y, and Z properties within the criteria range that we have there. And the system is going to spit out a mix, a proportion to you. So what you can expect from that mix, what do you need to have from cement, what do you need to have from sand, coarse aggregate, water, so even additives. So this is what the SmartMix will be able to help you with. And the goal is to determine strength simply based on the mix design input. So in the performance prediction, is a little bit different in this case. Within the SmartMix, this performance prediction, the goal, as I said, is to determine the concrete strength simply based on the mix design input. In this case, if you input your mix design, let's say 500 pounds of cement, 250 of water, based on how it was trained, based on thousands of mix designs from all over the world, and collected mixed ingredients and strength performance for multiple years, the system is going to spit out the performance prediction. And another thing, and how it works is this way. So we have our proportions, and the system is going to spit out the performance prediction. This is also true here. So the predict mix performance, such as compressive strength, workability, air content, based on mix proportions, raw material characteristics, ambient conditions, etc. So meet performance specification and prospective requirements such as specified slump, strength at different ages, minimum cement content as well. So the performance prediction implementation is close to the one that we're looking at mix enhancement. So we have our range that it could be fitted into, and we can predict the strength. And for the mix optimization, analyze and evaluate the influence of mix adjustments, such as use of chemical admixtures, so SEM, so supplementary cementitious materials on concrete performance, formulate concrete mixes at a minimum cost with a reduced carbon footprint, integrate Roxi, SmartRock's AI program with other concrete data management platforms using our comprehensive API, assessing more insights into the quality control and quality assurance of concrete. So this is the second layer I was talking about. So you can input what you need, such as I need 20 MPa, my slump is going to be this. I need, let's say, 6 inches of slump. So with this, it's the other way around. So the AI system is going to propose the most adequate mix design based on your requirements. In the optimization, going back, the user can specify if they want to optimize for cost or CO2 or both. So the program provides a list of mixes that satisfies the requirements with the optimized numbers. So this is just an example. In this case, we have for both, we have 312 of cement, the second option 309, then fine aggregate 736 or 738. So the system is gonna provide you a list with several different possibilities of mixes that are gonna be in compliance with your specifications that you inputted in the first place. So we are continuously improving our AI system. It's getting better and better. This is where we are at this moment. But wait, we're gonna have some news in the near future. We are improving our system. Our machine learning is learning every day. So tomorrow, Roxi is gonna be better than today. Today, she's better than yesterday. So this is what our system have been doing. This is how our R&D team have been doing in the past couple of years. So I wanted to thank you so much for your time today. This is the end of our presentation. If you have any questions, as I said, you can contact us at support@giatec.ca. Also, if you want a quote for our sensors so we can start benefiting from what we have, you can also contact sales@giatec.ca. I thank you so much for your time, and I hope you all have a great day.